Imagine giving an AI engineer a multi-million-dollar code base, give a full permission and working away. It runs out of memory and mid-task. It hallucinates a non-existing API parameter. It forgets what was building before 5 minutes ago, and it deletes the production file. That is what happens when you run raw multi-language models or LLMs without agent harness. This is Salam Lak, and I build AI agent and AI systems for business. Today we will discuss about what agent harness is, and we will cover what's the meaning of agent harness, why we need agent harness, and how does agent harness work, agent, model, and harness, what are the difference, and 8 building blocks of agent harness of production ready, and we will see harness, orchestration, and framework. What is the difference? Is agent harness and frameworks like LangChain and LangGraph are the same, or there is a difference? And we will cover also what agent harness engineering is. See what was the difference between agent engineering, harness engineering, prompt engineering, and context engineering. Let's get into it. Agent harness is a software infrastructure that works around LLMs, and it connects to an external tools, memory, and sandbox and database. Like a model acts as a brain that generates a decision, and the harness serves the execution environment and the physical interface. It handles execution, error recovery, state persistence, and guardians. Why we need an agent harness? Okay, LLMs are stateless. It means every fresh session is clear a failure memory. Without harness, 4 specific system failure occurs on long tasks. The first failure is unfinished single shoot rule. That means models run out of the context at mid-implementation. The next session waits a token guessing fast progress. Second failure will be a false completion fail. Means it is subsequent session spot a partial work and report a success without testing. Third failure, it is a context routes. Context window fill with route to output and log. The model lose original task instruction. Fourth failure is hallucinated tokens. Models may call functions with incorrect parameters, without interception, then burn API token on the retrace. Anthropic traced a cloud 4.0 opus without a harness on a web app build. The model failed completely across multiple context windows. And now let's see how agent harness works. The harness operates in 4-stage react loop that reason, act, observe, and repeat until the work done. Reason is a model or LLM reads a current context and choose an action. Act is a harness interprets the choice, validate parameters, and run an action in the sandbox. This is a harness. And observe that in observe stage, a harness capture output, clean it, write it back to the context, and make it ready for the next task. And repeat, the model will repeat, read, update, pick the next step. Now let's see what is the difference between model, agent, and harness. So those 3 terms describe separate layer of one system. A model that predicts a token and generates a text. It is a reasoning engine, or we can a brain. And harness is run the tools or that connects the model to external tools, a persistent memory, and enforce rules. It is a runtime infrastructure, another one. An agent is a combination of 2, that model plus harness, and it is operational worker. So the model generates intent, The harness validates, executes, and records the intent. And the agent is the environment or the operational worker that does the combination of those two tasks. Now let's see the 8 building blocks of the production harness needs. A production harness requires 8 core software components. The first is a system prompt. It is a standing rule injected before every run to define a boundary elements. A tool and a tool execution. It is an API adapter and a code interpreter. Developers use an agent code writing a capability instead of fixes function lists. The third is sandboxes. It is an isolated execution environment, and the sandboxes stop agent code from altering production infrastructure directly. And there is a file system and storage. A local disk or a database where an agent saves plans and code across roles. A memory management, a system that streams all the context log to prevent a model context overload. And there is self-verification loop. It is automated test that runs after execution to catch syntax and logic error. And the guardian, it is a permission check requires a human approval before file deletion or database writes. And the last is observability. It is a step-by-step cross logging for debugging and audits the compliance. Let's see now the difference between harness, orchestration, and the framework. Those software layers handle a different part of the task. Like a framework is a software library that provides a basic building blocks like a LangChain and LLM index. An orchestrator is a control logic defining when and patch order models run. That means it defines the order of the models. That orchestrates the models when and what type of model it should run. And the third one is a harness, as we are discussed a little, and the active runtime it is an environment managing tools, sandboxes, memory files, and state saves. So a memory gives you a piece. Orchestrator routes the traffic, and harness executes the work. Now let's see what is harness engineering is. Harness engineering treats an agent error as a system bug. When an agent fails, the harness engineer changes the context layout, sandbox permissions, or testing checks. So the engineer stops rewriting your prompt. They alter the execution environment to the model that cannot make it the perfect error again. So we have seen that the prompt engineering, the context engineering, and harness engineering. What is the difference? That what the AI system design moves through 3 structural stages. First is prompt engineering. It is a structural individual input strings. A context engineering is a selecting a relevant document for a retrieval augmented generation pipeline. And harness engineering is building a complete real-time system, including storage, sandbox, verification loop, and security guideline. Prompt and context design live inside the harness. The harness control part next enters the context window, and what happens after output generation. So an agent combines a reasoning model with execution infrastructure. The model handles the decision making, and the harness manages tool calls, context files, sandboxes, and verification loop. You build a harness when you're running a multi-step autonomous task across long time frames. A strong harness that turns non-deterministic model output into a reliable system execution. So this was all about the harness and agent harness. If you like this video, please subscribe. Thank you very much. Thank you for watching.